So a practical use of the rational root theorem is not only to create a list of the possible rational roots, it's then to use that list of possibilities to help actually find the actual roots, which can help you to factor. So we're going to use the rational root theorem to factor cubic polynomials where grouping does not work. So we're going to go back, if you watched the previous video, to the same equation, x cubed minus 7x squared minus 28x minus 20. And I just went ahead and copied down the list of possibilities. And what I'm going to do is I'm going to actually double list them out. So we have +1 and -1. So I'm just going to list all the negatives underneath of them. And then erase all those minus signs there. So I really have 1, 2, 3, 4, 5, 6, 12 possibilities here. So we know from the remainder theorem and the factor theorems that if you use synthetic division with these root numbers and it comes out with a remainder of 0, that number is a factor. So what you want to do, so like step 1 for this, or step A, I guess I'll use, right? Right, you want to use synthetic division with f of x and the PRRs to find a factor. Right, and that means that there's no remainder, right? Remainder of 0. So there's really not a great way of like guessing and checking here. So all I'm going to do is say, okay, let's find one that works. So say I'm going to pick 1 first. So what I'm going to do is I'm just going to set up a generic synthetic division. So I have my 1x cubed negative 7x squared. Whoops. I have negative 28 x's and negative 20 constants. So the first number I'm going to check is +1. Right? That seems like it's probably the easiest number to check, so let's check it first. So drop down the 1. 1 times 1 is 1. Add down to get -6. Multiply to get -6. That's going to give me -34. -34. Okay, that's not going to be a 0, so this one doesn't work. Oh, what I should have done is copy and pasted this. There we go. So now all I'm going to do is I know I can copy and paste because I'm on a tablet and you're probably on paper, which you can't do, but right, so you get the idea. You're just going to write it again. Okay, so say I'm going to test -1. Right, so I'll drop down my 1. 1 times -1. Add down, I get -8. Multiply, I get +8. Multiply down here, and we're going to get -20. And then multiply again, I get +20. Oh boy, it works. Right, so this one is an answer. Right, so x equaling -1 is a factor, is a root, rather. Right, which means, so think back to how we go from factors to roots. We have something equal to 0 and we solve for x. So if I make everything on one side, so like if I add 1 here, that means that x plus 1 is a factor. So right now, once I have this, I now have that f of x is going to be equal to my factor x plus 1 times my leftover stuff. So remember, if we go back to our leftover in our synthetic division, if I drop the powers down, I have 1x squared minus 8x minus 20. So once we find one factor that works, you could continue doing synthetic division and testing the other ones, but you don't have to. Right, so my second step, right, is either factor the remaining quadratic or continue to test the PRRs? Right, so I'm going to choose to factor. So x squared minus 8x minus 20. I want to multiply to negative 20, but add up to negative 8. So I know I'm going to be putting x's here because my a value is 1. Okay, so I know that if I multiply negative 10 and positive 2, I get negative 20 back, and if I add, I get negative 8. So those numbers will work. So my total factored answer, my factored form for my original function f of x, is going to be f of x is equal to our original x plus 1 times x minus 10 times x plus 2. So that's how you can use your PRRs to factor a polynomial when grouping and other factoring techniques don't work. So why don't we do one more example here? So I'm just going to look back at our g of x function, so that we did earlier in the other video. So 2x cubed minus 5x minus 10x minus 8. That's a squared. So what I'm going to do is I'm going to just scroll up and get our PRRs from the previous video. Right, and all I'm going to do is I'm going to double write them so that way I have my list ready to go. So I can also have negative 1, negative 1/2, negative 2, negative 4, negative 8. Okay. So what we're going to do is we're just going to first test out some numbers. So the first one I'm going to test is, well, first of all, I'm going to make my little division table. So I have x cubed, x squared, x, and constants. And I'm going to be smart this time and copy it before I write on it. So the first number I'll check is, we'll check positive 1 again. Okay, so I got 2. 1 times 2 is 2. Add, I get negative 3. I'm going to get negative 3 here. Add down to get negative 13. Okay, that's not going to equal 0, so positive 1 does not work. Okay. So let's test negative 1. Okay, so I've got 2, multiply and get negative 2, that's negative 7. I'm going to get positive 7, that's negative 3. Right, that's not a 0, that's not going to work as well. So why don't we do the 1/2 and see if that works? And that way I can also show you how to do synthetic division with a fraction. Okay. So 2 times 1/2 is 1. Add down to get negative 4. Half of negative 4 is negative 2. We get negative 12. Half of negative 12 is negative 6. Okay, that doesn't work either. And then I could test negative 8, negative 1/2, right, all of those numbers. I'm just going to jump ahead, and I'm going to test 4. So we're going to drop 2, multiply to 8, that's going to give me 3, multiply to 12, add to get 2, multiply to get positive, woohoo, it works. So we're left with 2x squared plus 3x plus 2 here. And if x equaling 4 is a factor, is a root, whoops, that's the wrong word, right, then we know that this is x minus 4 was the factor. So right now we have that our g of x function is x minus 4 times 2x squared plus 3x plus 2. So I want to see if this can factor. So I'm going to go off to the side. And there's a couple ways to determine if something will factor. You can just try factoring it, and if you can't factor it, it probably doesn't factor. You can also find the discriminant. And remember, that's b squared minus 4ac. So b squared is 3 squared minus 4 times a is 2, and c is also 2. So that's 9 minus 8 times 2 is 16. That's negative 7. So that tells me this doesn't factor. So if the discriminant is not a positive perfect square, then this does not factor. So because negative 7 is one negative and 7 is not a perfect square, this tells us that this is prime. So our final factored form is actually what we already have right there.